Okay.
Okay. Assalamualaikum and very good evening to Dr. Amallah and all my friends. Okay, today we are from Group 5, want to do the presentation about the flip-flop. Okay, first of all, I would like to introduce my members. My name is Nazirah binti Ibrahim. My matric number is 183812.
My name is Muhammad Syawal Mazni. My matric number 183871.
Okay, my name is Muhammad Aiman bin Wakidin. My matric number is 183401.
3.
My name is Lim Chin Sing. Metric number is 184127.
3. Okay.
Okay, let me proceed to the presentation. Okay, here our group are given 4 type of flip-flop, which are JRS flip-flop, JK flip-flop, T flip-flop, and T flip-flop. Okay, for our groups, we choose the T flip-flop. Okay, for the introduction, the basic building blocks of combination logic gates are gates, which are AND gates, OR gate, and NOT gate. Okay, for the flip-flop is the basic building blocks of sequential logic circuits. Basically, a flip-flop has 2 inputs. One input is a control input. For a T flip-flop, the control input is T, and the other input is the clock. Okay, T flip-flop is a device which swap or toggles state every time it is triggered if the T input is the excited. Otherwise, it holds the current output. So, this circuit is symbol for the T flip-flop, and the below of the T is the clock. And T is the toggle input, and Q is the store data output. Okay, here when T is held high, the toggle flip-flop divides the clock frequency by 2. For example, if the clock frequency is 4 MHz, the output frequency obtained will be half, means 2 MHz. Okay, a flip-flop also can be built using a JK flip-flop, which J and K pins are connected together and act as T. And it also can be using a D flip-flop, as T input and Q are connected to the D input through the XOR gate. That's all.
3.
Okay, thank you to Nazirah. Okay, now I would like to discuss about the truth table of the T flip-flop. Okay, as we know, basically T flip-flop is the combination of R and K flip-flop. Sekejap.
3.
Okay, thank you to Nazirah.
Oi, 3.
Okay, as we know, the T flip-flop is the combination of J and K terminal in the JK flip-flop. So it means the T flip-flop only need one input. Okay, now we look at the truth table. Okay, the characteristic of the truth table of T flip-flop, it has 3 columns. That first column represent to T. T is control input. Second column is current state, and third column is the next state. Okay, as I mentioned, the T flip-flop only need one input. So if we set the T equal to 0, the condition is same. But if we set the T equal to 1, the condition is changed. Okay, for example, we look at the table. Okay, when we set the T equal to 0, so the next state are equal to the current state. Same with the second row. If we set the T equal to 0, so the current state, if current state is equal to 1, so the next state also equal to 1. But if we set the t equal to 1, the condition is same. Like if the current state equal to 0, so the next state opposite output equal to 1. If the current state equal to 1, so the next state is 0. So
3.
The operation of the operation is if t equal to 0 is whole, but when the t equal to 1, the operation is toggle.
Okay, just
3.
okay. Thank you to Syawal. Then I will proceed the
3.
okay. If you look carefully the table is look like XOR gate, right? Because when 0 0 it becomes 0, and 0 1 it become 1, and 1 0 become 1, and 1 become 0. So why is this not XOR gate? Because if you look for the second column and the third column, the output is same, the output is different, but the time is different. And for the XOR gate, there are usually 2 input, but in this T flip-flop, there's only one input. Okay, so we move to the graph, the diagram. Okay, then this is timer 1, T2, T3. T is input, Q is the output, and Q bar is the second output. Okay, then for the T1, we look at the input. If the input is 1, so the output Q will become 1. From 0 to 1, it will change because we refer based on the input. If the input is 1, so the Q will change from 0 to 1, and the Q bar will change from 1 to 0. And then for the T2 is also the same. The input T is 1, and the Q and Q bar will change until T3. At the T3, at the T3, the input T is 0, so the output will unchanged, which is Q is 1 and Q bar is 0, so it will not change until T4.
Okay, so we goes to the application of the T flip-flop. As you know, the T flip-flop has 3 types of applications. The first one,
1, 2, 3.
okay, the first one application is frequency divider. Second one is the binary counter that use the theory of frequency divider. The third application is the 2 bits parallel load resistor. So we proceed. First application is the frequency divider. So below is the setup of frequency divider using T flip-flop. You can see the T flip-flop is all the same with the normal T flip-flop setup, but the output Q bar is connected back to the input of the T. This will make the output will become frequency of F/2, like just now the introduction also saying already. Next. So the working principle of the frequency divider is we can observe the behavior of the output of a T flip-flop by looking at a timing diagram. So this one is the clock input, Q is the Q bar input, and Q output and Q bar output. So you can see at every positive edge of the timing diagram, Q will be toggled. If the clock toggles to 1, then the Q also will toggle, right? After that, you go to the next positive edge, you can see the clock toggle again. So now this Q will toggle back 1 to 0. Then proceed, toggle again, then Q also toggle again. This process will continue until the end of the clock. So now, what can you discover from these two timing diagrams? First, you can see that the frequency is becomes lower, right? You can see in one timing, the frequency of clock is one complete circle, right? But at the Q, you can see in this interval of timing, they are only half cycle. So we can conclude that the frequency of the output now become half. This is how we can make the frequency divider that divide by 2. So if we keep feeding the output of one T flip-flop into the clock input of another T flip-flop, that the input is hardware to 1, and we do this for n flip-flop, then what is the period of the output of the last flip-flop? That means just now we only connect one flip-flop to another flip-flop only, then the frequency is divided by 2. If I connect to 10 or 20 or 11 like that, what is the frequency now? So the formula is 2 power of n times t. That means if you connect 5 t flip-flop together, then the period will become 2 power of 5, that means 32t. That means 32 times lower than the original frequency. Okay, so next. So this frequency divider theory we can use in the binary counter. So this binary counter is the second application of the T flip-flop. This is the setup of binary counter. You can see, as usual, clock is connected to the input, and T input is 1, and the output Q bar will connect to the next T flip-flop, and so on and so on. Then the output will become X0, X1, and X2. So to understand binary counter, we must go to the table of binary. You can see this table. Do you discover that this is more similar to the binary number from 000, 001, 010, 011, 100, 101, let's proceed. This is the binary number system, right? So the important thing in this table is you can see the period, the frequency. X0, 1 is always changing from 0 to 1, 1 to 0, 01, 01, 01, always changing. But in the X1, X1, if you remember the frequency divider theory, you can see that the frequency will become 2 times half slower, right? So you can see this X0 toggles only when 2 row. That means at the 2, then we'll toggle back 0011, 0011, like that. So the next will become more slower. That means 0000. That are 2 times slower than X1, 4 times slower than X0. 0000, 1111. Then continue is 000, like that. This is how the frequency divider theory used in the binary counter. Next. So this is the timing diagram of the binary counter. The clock as usual, then X0, X1, and X2. Okay? X0, X1, and X2 is the output. So you can see when the clock toggle to 1, then this X0 also will toggle. But X1 and X2 won't toggle. Why? Because X1 and X2 only toggles depends on the negative edge of X0. That means reflection, negative edge of X0, that means the X0 bar, reflection of X0. Okay, you can see when the X0 go from 1 to 0, this will toggle. X0 from 1 to 0, the X1 will toggle. Why? Because when you draw the negative edge of the timing diagram of X0, you can see that negative edge is toggle from 0 to 1. That means here also toggle from 0 to 1. Right, then you proceed. X2 is depend on X1, the same theory as X1 and X0, the relationship is. So you can see when the X1 toggle from 1 to 0, the negative edge will go from 0 to 1, right? So X2 also will toggle. this process will go on. When every negative edge of the x0 or x1, then consecutive x will be toggled for the next every negative edge. Okay, can you understand? So after you draw all the input-output timing diagram already, you can find that when you label 000, 001, this, you can discover that 000 is the first number of binary system, 001 second number, 010 third number, and so on and so on. So this make into a binary counter, like a binary counter system. So this binary counter usually will use in the odometer. The odometer is using binary system, but if you want to connect, this is the example of 3 bits binary counter, but if you want to use more bits, okay, you can connect more T flip-flop to it, so that if you connect 5 flip-flop, you can get 5 bit. That means got 2 power of 5, 32 numbers. If you connect more, then you can get more number possible for the binary counter. Okay, next. So the last application of the T flip-flop is 2 bits parallel load register. So we use register and shift register to store the data. But the storage of data, the size is always a primary concern for memory. So memory elements such as register. So we use 2 bits parallel load register instead of 4 bit, so that 2 bits is easier to store. You can see 2 bits, that means 2 T flip-flop. 2 flip-flop and 2 SOR gates and the max. This is the setup of the parallel load register. Okay, so I think this is all for the application of T flip-flop. Thank you. So in conclusion, I can conclude that T flip-flop is also called toggle flip-flop, that at every positive edge of the input or clock, the output of the flip-flop will be toggled, either from 0 to, the clock is 0 to 1, then the output also will toggle, either from 0 to 1 or 1 to 0. So this is all for T flip-flops. Thank you.